Hi everyone, are you able to hear me and see the screen clearly? Hi everyone, I'm Sandeep Giri. I'm going to be the instructor for this class. To answer my questions, you can use the chat window. Great, great. Wonderful to have all of you in the session. I'll try my best to answer your questions as much as I can. Please use the Q&A window if you have questions. And if you have something to say about yourself or you want to answer a question that I'm asking, use chat window. I'm going to keep my eyes on the Q&A window so that I can answer your questions properly. All right. So I'm going to keep my eyes on the Q&A window while if you have to say something to the panelists, use the chat window. All right. And me and my team is going to answer your questions. These sessions are very much question answer oriented. And this is an introduction session on big data with Hadoop and Spark. We will do the hands-on towards the end, and we will have a 10 minutes break in the midway. So the format of the session is going to be that the session is going to be 3 hours. We'll start with the agenda, start with introduction to big data. We will discuss what, why, and use cases and various solutions. Afterwards, we will take 10 minutes break, and then we will dive deep into Spark and Hadoop architecture, followed by hands-on. So followed by hands-on, as in we will go through CloudXLab's the Hadoop and Spark installed in CloudXLab and give you an overview as which component is where. And we'll try our best to demo the hands-on while discussing the architecture. All right. So the hands-on and architecture is going to be mixed up, and that's what I planned. All right. So please feel free to introduce yourself using chat window. We may not be able to respond to every chat, but we'll try our best to answer your questions using the Q&A window. This session is going to be recorded, and the presentation as well as the recordings are going to be shared with everyone. So do not worry. In case you want to take screenshots, in case you want to write a blog, feel free to go ahead. And this is the first of 20 sessions on big data with Hadoop and Spark. All right. The session is the course as such, the specialization course is big. This session serves as an introduction to the entire technology stacks. Those who are self-learners or those who are just looking for an overview, this session should be sufficient for everyone. Sufficient for those who are just looking for the introduction. While those who want to go for the full specialization, especially those who are trying to switch their careers into big data and Hadoop and Spark, or as a data engineer or big data engineer, big data architect, those who want to switch their career into big data, they would prefer to go for a full specialization. Full specialization, I'll talk about it in detail. And to ask a question, please type in the Q&A window. Except for myself, everyone else is muted. Otherwise, it will be impossible to communicate. Instruction will read. I will read out the questions before answering. To get better answer, please keep your message short and avoid the chat language. Not too short, not too big. All right. So please try to keep your message as simple as possible and as clear as possible. All right. I'm going to read out the question so that it gets recorded in the video, so that when you are reviewing the video, you have the context. All right. So feel free to ask as many questions related to the topic that we are having right now. Questions related to the career, please feel free to write to us or come over to the discussion forum. We have a very vibrant community where there are more than 50 people concurrently logged in on our community. All right. So feel free to log in and log into a discussion forum. If you go to CloudXLab, you will see the forum at the top right. Also, the lab is free for everyone for 1 week. And for the learners from academia, those who are from education institutes, the lab is free for them for 1 month. So feel free to sign up with CloudX Lab to experience Hadoop, Spark, data sciences, and machine learning, as well as deep learning uh, yourself. All right. So it's a single place where you can get all the tools required uh, without any installation. All right. You just have to do KYC, we call it know your customer process, so that we get to know about you a bit, and that's all. Wonderful to have all of you in the session. I'm going to turn off the video and um, and get into the course. All right. Are you able to see the Q&A window? If you have any questions that you want me to answer, please drop the message in the Q&A window. All right. So I'm going to take like periodic breaks so that I can answer your questions. All right. About this course is a full deep dive and one of the best courses on the internet available online. And this course has two formats. One is self-paced course in which everything you will get recorded. And the second one is the live course, just like this one, except for a smaller group of people. Today, there are going to be more than 100 people in the session. 72 are already there. And but from second session onwards, it's going to be only those people who have enrolled for the course. To enroll, you can go to cloudxlab.com and for attending, that way you will be able to attend the second session onwards. So this course is very hands-on course in which you have to log into CloudXLab, do the assessment, do the exercises, and system will assess you and give you the grades. So that's something that is unique about these courses, because these courses have been designed such that you will be able to enjoy the course and will be able to complete without distraction. So this is one of the courses which people on the internet are able to finish by themselves without too much of external motivation. All right. So that's something that we are specializing in. We are building these courses which are very, very engaging. All right. So feel free to join the course, and there are a couple of seats, around 5 seats remaining in the course. And we generally have, for the live sessions, there are only 20 spots, out of which only 5 are left. While for the self-paced, you can enroll at any point of time. And whenever you feel like that you want to upgrade to a live session, live course, you can upgrade by paying only the delta, only the difference. So great, great to have all of you in the session. I'm going to just give you an overview about CloudX Lab. So at CloudX Lab, we are making learning fun and for life. All right. So making learning fun and for life. How? By the way of videos, by the way of quizzes, by the way of hands-on, and by the way of projects and case studies. All of this is based on real life case scenarios. And one of the things that we have innovated is in the automated hands-on assessment. This one forces you to become hands-on with the technology. Watching the videos at your comfort is not sufficient. You will have to log in, and only then you will have to log in and start working on the components. Only then it will approve your assessment. All right. So the way it works is there's a problem statement and there is a lab, and then once you have done the work as given in the problem statement, it will assess and give you the grades. So this is how it works. So let's say here it's giving you a challenge that, hey, log in into CloudX Lab. Once you're done, then it'll give you the grades. All right. The second form of assessment is using the Jupyter. On left hand side, you will see the problem statement, and on the right hand side, you will have to you will have to define it. Right on right hand side, we call it a notebook. Notebook is the standard environment used by data scientists across the globe. And we are going to enable the same thing for people who are doing the Spark and Scala and the entire course. So essentially, on the right hand side in this notebook, you can do anything, whatever you wish to. Along with that, if you solve the problem given on the left hand side, the assessment will automatically check whether you have done it or not. Like for example, here it's asking me to define x as 10. Once I've defined x as 10 and do something whichever I want, then I can, when I click on I'm done, please check, it says good job. So this is a classic example of experiential learning. This is something that we are specializing in. We are trying, we are trying and we have built a very highly engaging system in which we connect the end user to the jobs, and we measure how well the person has done based on these assessments. So this is something we are specializing in, and we are working hard to make the learning fun and for life. All right. Great to have so many wonderful people in the class. People from across the globe are logged in. I can see from California, Malaysia, and India, Indonesia, and I have Kuala Lumpur, and there are people from Virginia area. Wonderful to have all of you in the session. And we have people from Atlanta and Manchester in UK and so on. Wonderful to have. I'm really happy to have people from across the globe. We have Clement from Beijing, and that's something I feel great about my audience, that we have learners from across the globe. All right. So, and such kind of class is very rare. In a typical class, you will find at least 6 time zones in in a usual class. All right. So the diversity is something really valuable in our classes. Great, wonderful to have such a great audience. Feel free to ask questions, and our sessions are all about asking questions. All right. The asking question is something that we reward, as well as we expect any kind of questions. Do not worry. Do not worry that your question will be stupid or so simple, obvious. No, every question is important. And trust me, I have taught for quite some time, and I understand that any question you ask, there are 50% people in the class who have the same question. It is just that they are not asking the question. They have hesitation. So by asking question, you are not stopping the class. Instead, you are helping the class. So ask the question. That's the only way to learn. That's the only way to um, improve in the career. All right. So that's the reason why we run these sessions, and I completely thoroughly enjoy the classes. Also also, even if we have to give extra sessions, it's completely okay, as long as everybody's question is answered. All right. So stay focused and be considerate to everyone's question. Some of us are too hard pressed for the time that they want to quickly skip ahead and want to ignore everyone's question. Trust me, when you try to answer somebody's question in the class, you will realize that you have improved. All right. So, and when you go for interview or go for career change, you will realize that these questions, the one that are being asked by your classmates, are very important, and you will learn a lot from them. All right. So that's something very important for our class. Yes. A question is, if you do the instructor-led training, then also you will get the lab as well as the self-paced course. All right. Both of the things you will get. Wonderful. So I'm Sandeep Giri. I graduated long back from IIT Roorkee, and I have mostly worked on large scale computing. I worked with a company called DE Shaw. DE Shaw is a very interesting company. At DE Shaw, we did distributed computing long back in 2002, and we had 10,000 node cluster. Afterwards, I worked with InMobi and Amazon, and in the midway, I founded a company called Tbits Global, whereby we built a large-scale document management system. So, so I have most of my career, I have been a software engineer or a machine learning engineer. I have built the distributed systems, normal web applications, as well as the mobile apps. And I have also done machine learning as part of my career at Amazon, InMobi, and at CloudXLab. So I, at the heart, I am software engineer, and I enjoy explaining technologies. So that's the reason why we started CloudXLab, right? Because we love explaining technologies to everyone, and that's why we have probably the most vibrant community on Meetup as well as outside. All right, so great to have all of you in the session, and I look forward to have a very rich interaction with all of you. This course is as part of this course, you will learn to process big data using using Hadoop and Spark. First, as part of this course, we are going to go full stack in Hadoop. We will learn HDFS, we'll learn Yarn, then we will learn, before that we learn Zookeeper, and then we will learn Hive, and afterwards we will also learn basics of MapReduce, and then we are going to learn Scoop, Flume, Uzi, and other components that are required. Afterwards, we are going to start with Spark. We're going to start with Spark, and before jumping into Spark, we will learn Scala, because Scala is something that is in high demand. So we decided to move to Scala from Python, and that has been a very good decision for lots of learners. In Spark, we will go entire stack, and you will learn. Yes, thank you, Clement. I missed to mention that. Yes, we will go into NoSQL and HBase as part of Hadoop. All right. So. And regarding NiFi, Banana, and Apache Solar, those things are not going to be covered in this. Probably we will launch a separate course for that. All right. Wonderful set of questions. A question from Ankit is this a certification course? Is this a certification course? If yes, then what is the parameter for measuring the test? All right. So we have projects as mentioned by Abhinav, and we will give you a certificate by CloudXLab. The way we measure is you have to do the things in the CloudXLab as per the instructions, and only then your work will be approved, and there is no way to skip that part. All right. Wonderful set of questions. All right, I'm going to take questions every 5 minutes or so, and I hope you will all be patient with the questions. All right, so we are going to learn the entire big data stack and related technology as part of this course. This is the most exhaustive course on the internet, along with this is the most engaging and interactive course available online today. All right, so we'll start with the basics. This session is a very basic one. I'm going to stop the video now. We'll just focus on the concepts, and afterwards we will take the questions. All right, so wonderful to have such a great audience. So the first thing that we will talk about this again and again, structured data and unstructured data. Let's be clear about the definition. The definition is when we get the data could be either in structured format or unstructured format. Structured, structured format is something that is in tabular format, having a concise definition of the data. We know what are the columns, we know what are the data types. That's what is called as structured data. We know the fields, what kind of fields are there, and we know the fields data type. That's what is structured. Then the other extreme is unstructured data. The examples of unstructured data is like plain text file, in which we neither know fields nor we know the data types of the fields, right? And in the midway, there is something called semi-structured data. In the semi-structured data, we know what are the fields, but we do not know their data type. For example, XML or CSV, we know what are the columns, but we do not know whether this column has all the fields of a particular data type or not. And to convert semi-structured or unstructured into structured, we need to do ETL. All right, are you guys able to see my screen, everyone? Avdesh cannot see the screen. All right, wonderful. Avdesh, maybe try rejoining. Probably that'll be okay. Wonderful, wonderful to see that lots of people are able to see the screen. Now, the point that I was trying to describe is that when you have unstructured data in the form of, say, text file or images or some other data set, which we don't know yet that how to load it quickly in the form of table, we need to do ETL, extract, transform, and load. ETL is an industry term, and probably all those who are from ETL background will be needing to upgrade themselves to do ETL on big data. All right, so we're going to talk about that soon. So this is exactly, the ETL is something that's a big use case of big data tools. All right, next is the distributed system. This term we are going to talk about again and again. And before we talk about it, let's understand what does it mean by distributed system. So when we group the computers together to form a network, and we make these computers interact with each other in order to achieve a common goal, we call such a system distributed system. Distributed system is something where you have many computers connected together and trying to achieve a single goal. Now, connecting the computers is not sufficient. These computers should be able to achieve a single goal. For example, let's say you're trying to convert a raw data into meaningful data. Now, this process, if you can break down this process to be done by multiple computers, then we call it distributed system. Or, or let's say you are trying to do some kind of processing like machine learning or other processing, and you want this work to be done by many computers simultaneously. We call such a system distributed system. We are distributing our work to many computers. All right. Now, just to check if you are awake. So how many bytes do you think are there in 1 petabyte? Yes? Okay. Okay. That's right. It's 1024 terabytes. Okay. 1024 gigabytes is a terabyte, and 1024 terabyte is a petabyte. Now, that was a correct answer. Good that none of you actually searched on the Google. Otherwise, you would give the answer that is displayed on the screen. Great. Now, a question to all of you is, how much data do you think Facebook stores in a day? There's no penalty for wrong answer. Just feel free to answer what you feel like. Okay, so it just to check, it's just a trivia that, right? How much data do you think Facebook stores in one day? Around 600 terabyte. 600 terabyte is the data as per their record Facebook stores per day. That's that's really humongous. So so here the point that we are trying to make is that this kind of data is humongous. And a question to all of you again is a typical hard disk, typical storage disk that you buy for your computer is how big? Around a terabyte or 2 terabyte. That's right. So around 1 or 2 terabyte or maybe 500 gigabyte. Correct? So that means that Facebook requires 600 such hard disks per day, right? All right. So, all right. A question to all of you again is that what is big data? What do you think is big data? All right. A lot of data. Yes. Yes. Okay. How much? How do you say that, this data is big data? When do you say that? Good question, good point, Yashit. Managing tons of data and getting out useful statistical information out of it. Wonderful, wonderful. So, in very simple words, I think most of you have answered the question. Let me compile and put it in a right perspective. So, in simple words, big data means data of very big size. Data of very big size. How big? That you cannot process with usual tools. Now, when we process with usual tools, here there are two words that need to be answered. One, what does it mean by process? And what does it mean by usual tools? All right. Usual tools are something that are non-distributed, meaning the tools with which you are using on one computer, you cannot use such tools. Okay, cannot process meaning the kind of work that you want to do is also deciding whether your work will require multiple computers or not. All right, in simple words, the moment you realize that one computer cannot do your job and you need to go for distributed computing, then you will say that, hey, my work is a big data work, and we need to utilize a cluster of computers, and for that we'll need to use the big data tools. All right, the big data tools are not only Hadoop and Spark, there are many other big data tools. Great. So any data volume or the processing could be of different form. It could be structured data, it could be unstructured data. So you could be processing unstructured data to gain the insight out of it, or you may be processing the structured data to get the analytics or some kind of insights into that data. Now, there are three general characteristics of data. One is volume, whereby the challenge is the volume, whereby we need to store humongous data. That's the challenge. The second one is velocity, the data in motion, the data in motion, how to how to handle number of requests or the moving data. That's a part of the velocity. Third is variety, the data in many forms. Let me take example of each. Volume means, say you have a problem related to storage of huge data, that too reliably, such as you're trying to store logs of a website, or the storage of data by Gmail. That's a huge volume. The Facebook stores around 600 terabyte per day, and so does Gmail. On the other hand, we have velocity. Velocity is the problem involving the handling of data coming at fast rate. Number of requests being received by Facebook, YouTube streaming, Google Analytics, and so on. That's velocity. The third one is variety. Variety is data in many forms. The problem involving complex data structures, example, maps, social graphs, and recommendations. The, the variety, let's take a look at the variety in more details. Imagine that there is a huge map and you have to go from one point to another. Like Google Map, you have to go from one point to another. And you have to find a best possible path, best possible route from going from point A to point B. Now, such kind of problem requires processing complex data structures and processing so many routes. And therefore, such problems come under the complexity, or we call them variety. Okay, so essentially, even though the data could be smaller and it's not related to handling the velocity, there could be a scenario where, because of complexity of the data, you may require a big data system. You may require multiple systems to handle such kind of problems. Even if your data is small, your velocity requirements are low. All right. So in very simple words, thank you, Prasant, the kind of data which requires distributed computing is called big data. All of the tools that you're going to learn in this course are around big data systems. Okay. All of the tools will be also called distributed computing system or distributed tools. Also, it's also called as high performance computing. Okay, it comes under high performance computing. Great. Let me see if you have questions so far. Great. The questions have been okay. Great. Let me also see if I could. Okay. Great. Wonderful. Let's move ahead. And if you have any question, feel free to ask you using Q&A window. All right. A question to all of you is, how much time do you think it would take to read 1 terabyte from a hard disk? We are not talking about writing. We are only talking about reading. Yes? All right. Yes, it depends upon whether it's SSD or normal hard disk. Good point, Rajesh. So yes, let's say we are talking about normal HDD, that is hard disk drive. Great, great. So most of you are correct. And it actually depends on what kind of hard disk are you using. On an average hard disk, not like really high performance hard disk, it takes around six hours. It depends. It's a function of how many RPMs does the hard disk have. Okay, so those who gave the answer in hours, all are correct. Okay, and it all depends on what kind of hard disk are we using. All right. So if you have to count, now my next question to all of you is, if you have to just count vowels in 1 petabyte data every day, do you require multiple systems? As in, do you require distributed system, or you can get it done through a single system? Let's say you just want to count vowels in 1 petabyte data. And that too, you have to do it every day. Correct. Thank you, Yashit. Because to find out vowels in the data, we'll have to traverse over all of the data every day. And that would require reading the entire data. Great. Yes, most of the existing systems cannot handle it. Therefore, we'll have to store this humongous data on multiple systems, and parallelly, we will have to count vowels on all of these multiple systems. All right, let me answer one question from Yashit. Question is, so as you said that the big data handling requires distributed systems, does that mean that we cannot go ahead with big data analysis on our local PCs? Good question, Yashit. So probably all of you might be having a similar question. So question is that, can we go ahead with big data analytics or testing on our local PCs? The thing is, most of these systems, whether Hadoop, Hive, Spark, and so on, all of these systems have a local mode in which it can run only on one system. And you can, for learning and testing purposes, you can use your local machines, but it won't give you any performance advantage if you are just using one computer. Because as we just read, that the bottleneck is the hard disk drive. In most of the cases, the bottleneck is hard disk drive. We'll just talk about bottlenecks in a minute. And therefore, you will have to require you will have to go for multiple systems or distributed system. Wonderful. So great to have audience who is answering really well, and feel free to participate in the Q&A. It's okay to give wrong answer, because at least that way you will remember the right answer. All right. Now this is a little older graph whereby it shows that around 2002 the digital age began. The data, the digital storage started getting more and more consumed as compared to the analog storage. Analog storage is the paper film, and videotapes, etc. So as you can see clearly, in 2002, the digital storage suddenly exploded. Suddenly exploded in the sense that more and more data was being generated in the digital format. So this was the beginning of the digital era. Why did that happen? Why did that happen? Let's understand that what made it so. Just give me a second. All right. So what made the digital era begin? Let's try to take a look at the reasons. The first reason is the devices. The devices became cheaper, faster, and smaller. The other reasoning is connectivity. The connectivity improved. We got Wi-Fi, 4G, 3G, NFC, GPS, and so on. So many ways to connect, Bluetooth, and and so on. So a lot of ways of connecting the devices to each other became available. While on one hand, the devices like the phone, the the phones and the sensors and so on, they became faster, cheaper, and smaller. As of today, the phone that you're holding is actually faster than the supercomputers of 2002, the one that you use for playing Fruit Ninja or maybe. All right. So that phone is actually more powerful than the supercomputers of 2002. So the devices, and remember that this device, the phone that you use, has got more sensors than any other device available in the past. So the device is one of the more important reason why there is so much of data being generated every minute. Second is connectivity. So on one hand, you can think of device as data generators and connectivity as data multipliers. So, and these two things, the availability of device and connectivity has led to the usage in the form of various applications such as social networks, Internet of Things, and so on. There are every day a new service is available, and you can utilize the devices and the connectivity to create more and more services. All right. Now, another question that we ask is, what is so big deal about handling data? To jump into that, let's first understand vaguely. I'm sure that most of you know what it means by processing data. Most of you know that already. Let me just do a quick recap. When we say that it's a computer, what do we mean by it? We mean by these four things. First, the CPU speed. When we talk about a computer, the most important piece is CPU. What is CPU? CPU is capable of handling the instructions. Instructions are like go here, read this, compare this, jump to this location, and so on. That's what is an instruction. And the processor, which we call Intel or anything, it processes those instructions. It is able to take orders from written information. And that's what brings the data to life. So processor is is capable of taking a written instruction and executing it. So you can think of CPU as something that gives life to the computer, right? Second one is the when we talk about processor, the one thing that we always talk about is how many instructions can it execute per second, and mostly it is in gigahertz. The second one is RAM, the speed and the size. The RAM, speed, and the size. The third one is hard disk drive or SSD. When we talk about RAM, we talk about two things. One is called how much RAM do we have, and how much size we how fast can we read from it. So processor reads from the RAM the instructions and then executes them. Okay, so most of the data before getting it processed, we load it into the RAM and then process it. The third important thing is the SSD and hard disk. This is the storage which is permanent. The RAM is not permanent. As soon as you turn off your computer, the RAM, whatever is written in the RAM, goes away. So hard disk or solid state drive is something that's permanent. So we store data, transport data using hard disk We can even take the hard disk and go and connect to another computer and load it there, right? So hard disk is like a permanent storage unless we delete explicitly. So from hard disk, we load the data into the RAM, and then from there, the CPU processes it. For simplicity, I'm okay with not being precise. All right. So some of the things might look not very precise, but for simplicity, it's completely okay. The fourth component that we always miss out in a computer is the network. How fast can we load data from a different computer or another cloud or another machine? All right. So basically, these are the four components which matter. Let's say you got huge data, you can't fit into the RAM, so part of it you will put in the disk. In case you got really humongous data which you really can't put in one disk, you'll put on a network. And that way, when we process big data, at least one of these components become the bottleneck. At least one of these four components become the bottleneck. It could be the read speed of the hard disk that has become the bottleneck, or it is the size of the hard disk that has become the bottleneck, or the RAM has become the bottleneck, or CPU has become the bottleneck. So, or the network has become the bottleneck. So when we do the processing of big data, at least one of these components become the bottleneck. Bottleneck as in something that you cannot avoid. Okay, something that become the constraint. Okay, so these are the four components that are basically that are basically dictating how do you process your data. What kind of program should you write in order to process your data? These are four components which are putting the constraints on you. And this is exactly the problem that the computer programmer solves. All right. A question to all of you is, which of the following components impact the speed of computing? CPU, memory size, memory read speed, meaning the rate at which you can read the data from the RAM. Memory here means RAM, random access memory. All right. The disk speed, disk size, network speed, and all of the above. That's right. The answer is all of the above. So yes, this is something very important. So when we talk about computers, we should not be talking about only the processors. Like you have an old laptop, you can just replace the normal hard disk with a solid state drive. Suddenly, your computer will become close to 10 times faster. Similarly, if your computer's bottleneck is the RAM, you can upgrade the RAM and you'll find that your computer has become really, really fast. All right, great. Yes. So the answer is G. Let me answer a couple of questions. One of the question is from Devasekar. Do all the nodes need to be in the same local area network or in the same region in the cluster? Generally, yes, but it all depends on the software that you're using. All right. You can have the multiple servers. If you are talking about, say, Hadoop, you can have many racks, which are each rack is like an Almira in which you put the computers and connect with each other. So you can have multiple racks in your data center, and that means multiple networks. All right. So the Hadoop takes care of the network architecture. You can configure any kind of network architecture in Hadoop so that it understands your network and hence optimizes the network. All right. Optimize the network as in optimizes the processing using the network topology. Great question. Question from Yuvraj is, what is the maximum capacity required to run big data in local computer? So it all depends on which system are we trying to use. Say if you want to run a Hadoop virtual machine on your laptop, you might require say minimum of 8 GB of the RAM. Okay, and of course more than 20 GB of free space would be required. So I would strongly suggest that use a hosted lab such as CloudXLab. You can sign up for the CloudXLab and start using right away without having to upgrade your hardware, because everything can be done remotely using the browser on the lab. Great question. All right. Yes, Faz, you are pressing pluses. Is it like your key has been pressed, or you're just putting pluses so that you can demark the chats? All right, wonderful questions. A question from Ashwini is, how do you see Azure Cloud? We can any number of CPUs, hard disk, and memory. That's right, just that you'll have to pay to Microsoft for using all of that hardware. Okay, so yes, you can use Azure Cloud with Hadoop or any of these tools. A question from Bharat is, how much node can we have in the cluster max? Okay, all right. So how many nodes can we have in a cluster max? So there has been, uh, I'm not sure if Hadoop puts a restriction on the number of nodes, but I have heard about the clusters having more than 10,000 nodes. All right, great, wonderful set of questions. And all right, great. Moving ahead. Now, so far we discussed about the problem called big data. But the question is, if it's such a big problem, why do we need to use or handle big data? We can just delete the older data and be happy with it. Why do we need to worry about processing big data? Why do we need to do the processing of big data? All right, let's take some use cases and then I'll come back to your questions. Yes, thank you, Rajesh. Yes, one of the biggest use case of handling big data is using using it to give you the insights. All right. So let's take first use case called recommendations. And recommendations is such a wonderful use case that um, when Amazon launched recommendations for the first time, it basically improved the Amazon's sales by around 40%. It improved the sales of Amazon by around 40%. And that's the wonderful thing about recommendations. There are many forms of recommendations. One is people who bought this also bought, meaning we have no clue about the user and we're trying to answer their we, so we have no clue about the user's behavior, but we know that user is seeing this particular product and and therefore we can give other recommendations. The second example on the right hand side is very personalized, very hand curated, not personalized, hand curated, saying people who bought this also bought this. Now, from the user perspective, suddenly, when you are sending an email that based on your past behavior, we believe that you may also like to buy this, this suddenly improves the user experience. It suddenly helps user explore more product. Maybe the user doesn't like this one, they might like the another one. You are helping the user with the new choices. Okay, and this is exactly where the if you gave hand curated or let's say you wanted to give the recommendations based on who are the products you want to promote, then the users will think that you are trying to bombard them with the advertisements. And that's what most of the other e-commerce companies did at that point of time. They bombarded the users with 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 the ads. Okay, and that did not lead to a good user experience. But the recommendations are something really useful. Now, why big data for recommendations? We could just pick up some, sample the data and do recommendations based on that. The answer is, the bigger the data, better will be the recommendations. If, let's say, you're trying to figure out very similar users like you, if you have a bigger data set, will you be able to find similar users like you, or a smaller data set? Of course, bigger, right? If you have the bigger the data, the better the results you're going to get. Correct? The bigger the data, the better results you're going to get. Bigger as well as diverse data set is what is going to give you better results. So this is exactly where the recommendations are recommendations become really useful when we have big data. The other form of recommendations could be as displayed by Netflix. Based on your past history of watching movies, Netflix customizes the recommendations of movies to you. And this is exactly where many companies have started utilizing the big data to give the customized recommendation. And recommendation is the first use case most of the companies want to get into. All right. Now, how do they generally do it? Though it might look really complex, but the answer is extremely simple. You create a user. This is a very uh, simple way of generating recommendations. If you have your data already, you can prepare the user ID, product ID, and ratings, these three columns, and then feed to a system like Spark MLlib, and it'll give you the recommendations that this person may like this movie this much. Just based on this data, it'll try to figure out which users are similar and have similar taste, and let's cross recommend those. There are many algorithms available for recommendation in a library called MLlib, which is part of Spark. So to do the recommendations, you could use the Spark MLlib, which we'll cover in the course. We will do the movie recommendation as one of the exercises as part of this course. All right. So here, this is one of the use cases of big data. Now, the second use case of big data is e-commerce. In e-commerce is A/B testing. Like when you go to Amazon's website, you will find that the website that you see is slightly different from the website somebody else would see. Why? Because Amazon is running A/B tests. All right. Imagine that you want to find out whether this color is good or this color is good, whether red is better or green is better. Let's say one of your designers say that, hey, I want red here, and the other engineer says that, hey, I want green here. Now, how do we decide which one is better? The answer is, let's experiment and figure out which one is giving us better results. So what we do is, for let's say some users, we show one variation, and for other users, we show another variation. And then we observe the conversion ratio. Like these many percentage people did the buy in this, and 11% did the purchase using while they saw this color. So which one do you think is better color based on these numbers? Anyone? The variation A or variation B? So here 15%, 50% of the users are seeing the variation A, 50% of visitors are seeing the variation B, and out of whatever users came in, 23% purchased seeing the variation A, and 11% purchased using variation B. All right. So yes, Now, all of you can confidently say that, yes, variation A is definitely better, right? If this number was not given to you, probably you will say that variation B is better, correct? Yes. So this is exactly what A/B testing does. It lets you make decisions really well. All right. So and such kind of systems can be built using the big data systems, using the big data tools, using the big data architectures. All right. A question from Satish is that I believe there should be another property like varsity, uh, veracity. Okay. So Satish suggesting that there could be another fourth property in big data definition called veracity. So yes, veracity is another you know the characteristics of the data. So I want to keep away from all kind of additions. There is value, there is veracity, and so on. Every year people are adding one more v to the definition. So we want to stay focused on the purpose of the session. We want to stay focused on the definition of big data, that the big data is something where we talk about distributed computing. All of the tools as part of this course are going to talk about distributed computing. All right. Only this session that you have today is very theoretical, in which we talk about the general definition. From second session onwards, it's going to be heavily practical, and we are going to interact with the technology stack in order to learn big data and distributed computing. All right. So we want to avoid the noise being added by people in case of definition of data. A question from Haim Himsalekha, Hamslekha, and question is, how do you decide how long the old data needs to be stored for recommendations? A very good question, Hamslekha. That the answer is generally that do not delete any data that is representing your old users. Okay, why? Because storing data has become extremely cheaper. So the general thumb rule is do not delete any data which has the information about your users. Okay, so that's something that we always do. Even in the Facebook, we do. Facebook does the same thing, and so on. All right. A question is, let me just take these few questions and then we'll move with other big data use cases. All right. A question from Shiv Prakash is that if plenty of data can give better results, does it mean that we should not delete the older one? Yes, we have. We generally don't delete the older data. And question from Shiv Prakash is, can we store the results itself? Now, given the raw data, there could be many results, many kind of results or recommendations that you can have. Today, you have one algorithm to give the recommendation. Tomorrow, you could have different algorithm, or tomorrow when you are regenerating the recommendations, you might require raw data rather than the recommendations. Therefore, it is generally better to keep the data. At most, what you can do is you can clean the data, and so that the size it's taking becomes smaller. All right. So generally, as a rule of thumb, that we never delete the data, and because insights are always smaller and miss the original data. Therefore, the insights are not sufficient. Let's say you're just keeping the average value of purchase of the user, right? From the average alone, you cannot compute, say, median, or from the average alone, you cannot, say, compute the standard deviation. Therefore, we prefer to keep the actual data. Maybe we convert it into better format so that it can be consumed better, but we avoid deleting older data. That's a change which Hadoop brought to the psychology. Before Hadoop, systems like Oracle and Microsoft SQL or any other SQL, the storage of data was extremely costly. Now, storage of data has become really, really cheap, and therefore it's not worth deleting the data. Great question. Question from Devasekar is, what is the stream analytics in the context of big data? You can answer this question, and I invite other users also to answer the question using chat. In the meantime, I'll try my best to answer the question. Question is, what is the stream analytics in the context of big data? So when you have a humongous data coming in every second and you want to do some kind of complex analytics on this data, that is called the stream analytics. Sometimes that's also called unbounded data processing. Sometimes it's called stream processing, and so on. So all of this is part of the streaming analytics. And if you search the internet about the dashboard using Spark, you will find that there is a blog we wrote long back about the same thing. So here, what we do is imagine that you have, say, you are trying to process the data, or let's say you're trying to generate the sentiments from the Twitter, and a lot of data is coming every second. Okay, in that case, to do that kind of processing, you would require a big data system. All right, so that's called stream analytics, doing the processing in real time. A question from AK is, does big data replace traditional data warehouses? Does big data replace traditional data warehouses? Yes, yes. Most of the big data ecosystem is being used to replace the data warehousing, because one of the reasons is that the data in these organizations who were using the data warehouses has gone so big that they are not able to process using a single computer, and they require a cluster to solve even a simple problem. So yes, so most of the people are trying to replace the traditional data warehouses with big data ecosystem. A question from Sarvanan is, then it becomes an archival system if you store all the data and don't delete anything. Yes, so it can serve as an archival system as well. A question from Ankit, is there any kind of data which we need to delete? The data that's manually generated, that you think that is something that you can generate again, that you can delete happily. Okay. A question from Ravi is, life of data, if known, can it be deleted? Yes. If you can regenerate the data, then you can delete it. Otherwise, don't delete it. If we don't delete the, are we losing the relevance of current trend? So that's a luxury that we're talking about. So if we have, let me ask you this, if we don't have old data, can we generate the analytics on older data? No, right? But if we have old data as well as new data, we can do both. The new analytics on new as well as the older data. Therefore, you don't get additional advantage of deleting the old data, right? It's up to you. It's a luxury. It's up to you whether you want to do processing of older data or not. Or let's say you want to generate the trends of old as well as new and compare how well is the trend going, how how well it is going. So it's up to you. It's basically a luxury that you don't want to lose. Okay. A question from Naveen is, what are the different Hadoop setups used by most companies to store and processing? And also, what is Cloudera I have heard of? So using this to store and process big data, I'm going to talk about it very soon, Naveen. So either you ask the question again or just copy paste it again. I'm going to mark it done. All right. A question from Ravi is, how is stream distributed to the distributed analytics. Okay, so when you have the stream of new incoming data, the stream is basically moved to batches of data and to multiple computers. That batches of data, some part of it is on one computer, some is on another, and you do the analytics on top of it. If you're asking for a specific tool, we generally use Spark streaming for such kind of workload. All right, great question. Question from Prachi is in-memory analysis also part of big data analytics? We avoid doing that. In-memory analytics, if it is distributed, then it can be part of the big data analytics. All right, so wonderful set of questions. A question from Andy is, can all data warehousing concepts be implemented in big data, like maintaining SCD2 columns? So as of today, the big data systems, though they are capable of doing complex processing, but the software is not designed in the same way as data warehouse was designed. So to do a little bit complex processing like creating the cubes or creating like SCD, maintaining SCD2 columns, you might have to do manual processing using Spark or using say HBase. Okay, so basically you can achieve that, but you might have to write programs around it. As of today, it's not that sophisticated as the traditional data warehouse system is, but since it is distributed, since most of the big data systems are distributed, they're capable of handling humongous data. All right, great questions. Let me answer the question from a really long name. All right, so it looks like a hash of a big name. Let me, right, for recommendations, if old data is used and the user preferences changed recently, will the recommendation be corrected using the entire historical data? I mean, yes, it's a good question. Question is, if we have humongous data of say 50 years, will the recommendation be corrected using the recent trends? Yes. Imagine that you have to find the average value of something. So will the average change when you have new values? Yes, of course, right? But the impact of the history will be there, just like when we compute average of a list of values, right? So it is up to you how many months of data do you want to process. Say, for example, when I was working with InMobi, we were lucky to have stored all the logs since the day zero at InMobi, right? Because of which we were able to do a lot of wonderful processing, a lot of wonderful recommendations we were able to give to the users. So that was possible because we have stored the logs or the user behavior of past couple of years. Okay, actually past 6 years, 6 years we did that. Now, right now, it was we did actually ignore 1 year's data, and for some part of the processing, we only considered last 6 months data. We ignored the older data, but that was a luxury rather than a compulsion. All right, that's why you it's up to you as a data scientist or a data engineer to figure out which data sets to use instead of using the entire one. But generally, when you want to have a better look at the data, you would like to take into consideration a larger set rather than smaller set. Great question. I hope this is useful to everyone. All right, a question from Yashit is, the storing of recommendation for a product into database is done when the product is first accessed by the person, or when the person when the product is newly created. All right, a question from Yashit is that the storing of recommendations for a product. All right, so the answer is both. We call this problem as the problem of cold start in case of recommendations. When you have a new person joining you, signing up, you may not have history of this user to produce the recommendations. Therefore, you would like to create the recommendations for this user, as well as when you have the product which has no history, that also is a cold start problem. Now, the second angle to this is when should we recreate the recommendations? The general thumb rule is we create the recommendations in two forms. One is periodic, and second is whenever user is visiting a particular page. So one is real time, other is the one is real time and other is the history, the based on the base one is real time and other is batch wise. We do that both. All right, it's up to us, it's up to how much time it is taking for you to generate recommendations. All right, so we generally did it for periodically. A question from Yuvraj is, what is the difference between big data and data warehouse? Data warehouse was using the existing database systems, like relational systems, and data warehouse was not capable to be run parallelly on multiple computers, as well as most of the data warehouses have the bottleneck of the discrete speed. And when you have to process petabytes of data, you really cannot get the timely results with the traditional data warehouses. This is exactly why most of the companies are moving the data warehouses to the big data systems. Wonderful set of questions. Last question, then we will move on to the other use cases. Question from Prasad is, how do we store the data if there are any data privacy rules set by government or the customer? You have to follow the same, whatever is the privacy rules, and accordingly, you have to keep the data. You have to keep the data. The lifetime of the data has to be as per the rules in your country as well as in your industry. In your industry, let's say you are in a medical industry, you might have to abide by the FEMA rules, and there are quite a few rules. And if you are in a different country like Europe or US, you'll have to abide by that country's rules. All right. A question from Infinix is that who owns data in big data? At the end of it, whoever is storing and has taken the permission of the user to store the data. What kind of security is available? It is up to the way you want to store it. You want to keep the confidentiality or encryption in place, that you can enable encryption, and how it can separate good or bad data. There is no such thing called good or bad data. There's something called true and false bytes or bits. Okay, so good and bad data is up to the analysis. Once you have stored the data, you do the analysis and figure out that, okay, the whole data is just full of new line characters and is empty, and we need to delete all of this. That's bad data. Good data is the data which has diverse information about the behavior of the users, or or the information kept by the users. All of that is good data. You don't really, uh, unless you realize that the whole data is full of auto-generated things which you can generate at any point of time. Unless you figure that out, every data is good data. Good and bad data is always relative things. That's right, it's a relative thing. All right, so you can think of it this way, that you are you're building tools. It can be used for good or bad things. That is something I'm not expert at. A question from Dev Sekar is, all the big data processing is done behind the proxy and only exposed via service API. That's correct. Or you can have like a database driver accessing one of the services using say using say the standard TCP/IP way. Okay. All right. Wonderful set of questions. Moving ahead. Now, there are many other big data customers, such as government. Government does the fraud detection, and they're able to do it because they process humongous data. Similarly, they do the cybersecurity welfare using the data, looking at the data patterns, as well as justice. Okay, by seeing various cases, the government can do the justice, can figure out the similarity of the cases, go through the whole, go through a particular contract in a more meaningful way using the understanding from the big data. The telecom is another very big user of big data. It's not only the companies like Google and Facebook, but telecom. In telecom, almost everything is big data. One of the customers that I was working with long back, they had these configuration settings of every tower. Every tower's configuration was actually in hundreds of gigabyte size files. And then I looked at the file and then I realized that, okay, this is a classic case of big data processing. So, so you have like the customer churn prevention when you want to stop the customer, when you want to prevent the customer from leaving you, you would like to understand where did we go wrong and how can you figure that out by observing, by comparing the customers who left you or customers who continued with you, by comparing their past behavior and so on. Network performance optimization is a very big use case in telecom. Understanding where the network traffic is going to be tomorrow and optimizing the resources accordingly is a big data problem. The third one is calling data record analysis. Calling data record analysis that can be done using using big data systems because calling data could be really humongous. Also, the fourth one is very common, analyzing the network traffic or network behavior to predict the failure of the equipment or failure of the connectivity. So all of this is possible using big data systems. Similarly, in healthcare and life sciences, every data is big data. Whether it's about exchanging information or gene sequencing or healthcare improvement or drug safety. All right. So almost everything in healthcare is a big data problem. So almost every organization today is a consumer of big data, and it is going to be because as in the lifespan of a company or organization, they're going to accumulate more and more data, and they'll need to process it using multitude of computers at any point of time. All right. So now the question is, what are the available big data solutions out there? Somebody has already asked this question. So there are many solutions to handle big data. There are many solutions or many stacks that are available to handle big data. One of them is a combination of Hadoop and Spark. Hadoop and Spark is a very good combination. The storage of structured and unstructured data, you do it using Hadoop, while the processing of the same, people prefer to do it with Spark, though there are the processing engines available, alternative processing engines available on top of Hadoop. So Hadoop becomes like a place where we call it sometimes like a data lake. in which you could store the unstructured data as well as structured data, and then you can process that structured data using the tools such as Spark, such as Hive, and sometimes such as Apache Flink. Thank you, Deepak. All right, so there are many such tools that can process big data stored in a distributed way. While on one hand, Hadoop lets you store humongous data using many computers, using thousands of computers in the form whether it's structured or unstructured. If it is structured, we use HBase. If it is unstructured, we use HDFS. We'll talk about it very soon. So Hadoop and Spark combination can be used to store and process humongous data. The second one is Cassandra. Cassandra is a data store like your database, just that in Cassandra, you can store any kind of data. Also, Cassandra is a kind of a database which runs, it's basically a database which runs on top of many computers simultaneously in your network. So if one computer goes down, the traffic moves to another, and so on. So Cassandra is a wonderful and powerful place, powerful open source software in which you can store your structured data very well as semi-structured data can also be stored in Cassandra or MongoDB. These are the databases which run in a network. What is a database? Database is something where you can store the data in the form of tables and you can relate each other. But in case of Cassandra or MongoDB, these are called NoSQL databases. NoSQL databases, why? Because they don't have the same rigid structure of the SQL as the traditional databases like Oracle or Microsoft SQL or MySQL. So Cassandra and MongoDB run on top of many computers simultaneously, and increasing more machines is really, really easy when it comes to Cassandra and MongoDB. All right. So a question from Ravi is any time series database? Yes. So you can actually emulate time series using either a specific time series database. I forgot the name. There was a very wonderful database that is being used for time series one. Or you can create a time series tables using MongoDB as well as Cassandra. All right. The the next one is using the cloud. Okay, using either the Google Compute Engine or AWS. Using any of these any of these clouds, you can out of the box use their service without having to worry about installation or worrying about purchasing hardware and so on. So you can simply use their services. You can simply use their services. Okay, a question from Prasad is, should we use AWS managed big data solution rather than Hadoop HDFS due to maintenance of the cluster owned by customer when to choose AWS? All right, so a question, this is a very important question before jumping ahead. So question always remains is that should we use our on-premise or should we use the cloud, right? Should we use the on-premise or should we use on the cloud? It is strictly up to you. If you, there are multiple things that you need to consider. One, when you are using your local cluster, it's going to be definitely cheaper as compared to AWS in terms of hardware. While in terms of maintenance, it might be more costly for you to maintain a cluster. Because if some machines go down, what are you going to do to maintain them and so on? Second, you might have to put your servers on the public IP if you want them to be used by your customers. And that's a big concern for many people because the up speed of your network might become the bottleneck. Also, you will have to maintain the uptime. Therefore, if you are making a customer facing application that you generally don't do, you're going to generally don't do with big data, you're going to inevitably use the cloud. Say, for example, in case of CloudXLab, we preferred going with the cloud like AWS or Google because we wanted to open it to our users. Had we been using it for our internal use where uptime was not important, then we could have just set it up in our office. All right. So that's yeah. So you have to consider all these parameters before going ahead with a cloud-based system like Google Compute Engine or AWS. All right, a question from Prasad. What are the tools available to move structured or unstructured data from on-premises to the cloud? So most of the cloud engines like Hadoop FS, Hadoop commands basically can be used to move the on-premise to the cloud. Okay, if you are moving from local to the Hadoop one. Similarly, for other tools as well, there are commands that can help you upload data from local to the cluster. Or you could use a system like rsync for moving files from on-premise to the cloud. Okay, I'm going to talk about this AK very soon. All right, a question from Dev Sekhar is Cassandra and MongoDB are for storage purpose only. Can they do recommendation like processing also? We need explicit computing engine to do that. Yes, though Cassandra and MongoDB provide you a way to process data, a way to query data, but still the abilities as provided by Spark are not yet available. Though using Spark, you can read data from Cassandra and MongoDB, but you're not going to get a similar performance. That's one of the reasons why people prefer a Hadoop and a Spark combination, because whatever Cassandra and MongoDB does, Hadoop also has a similar component called HBase. A question from Rajita is that how do we compare AWS and Microsoft Azure in perspective of cost? That'll be a very hard questions to ask. Most of the pricing of all these clouds is highly competitive, and the only way you can figure out is by observing your cluster for 1 month at AWS and 1 month at Azure. A question from Rajesh is, would you consider data stored in MongoDB as structured or semi-structured? All right, a hard question to answer. I would still consider the data to be semi-structured because the data is in the form of a complex though it is like a tabular structure, but it can be far more complex. So the standard query languages like structured query languages may not work on MongoDB. So I would consider that to be semi-structured, though other people might argue that MongoDB does provide you SQL queries like aggregations and so on that let you query the data, and from that perspective the data might look structured. So it's really hard to classify that data into semi-structured or structured. All right, good question, Rajesh. All right, so let's take a break for 10 minutes and we will be back after this. So we are going to talk about Hadoop, and then parallelly we will try to demo you on a new lab that we have set up, and then we see that if it is we can give you a real demo of the tools in the lab. Okay, so let's take a break for 10 minutes and back by 5 p.m. IST. All right, so I'm going to take a break for 10 minutes. All right, so I'm going to put it here. Hi everyone, are you able to hear me and see the screen clearly? All right, so I'm back. Should we start now? Great, wonderful. So, all right, so let's get started. And there are a few questions that I would like to answer before going ahead. A question from Rachna is that in big data environment, where do we use databases like Cassandra and MongoDB? All right, so when you have humongous data, and that's more or less read only, then you generally go for a file system or in the form of Hadoop, HDFS, and so on. But if you have the data which is being modified, not appended, modified continuously, then you go for systems like Cassandra, MongoDB, or HBase. All right. So another question is from Ravi. Not clear how Spark works better with Hadoop and not with Cassandra or MongoDB. As I understood, after the model is trained on historical data, the incoming data will be processed by Spark. So where does Hadoop and MongoDB come into play, right? So Spark is a processing engine. It does not, it does not store data. It does not have a data storage. For storage, it either depends on like Hadoop file system or MongoDB and other systems. In most of the cases, when Spark is able to run the program nearer to the data, then it is generally faster. Therefore, in case of Hadoop file system, it is able to run the program or run the logic nearer to the data, and therefore when it's processing the data from Hadoop file system, it is generally faster. All right, that's why Spark would work far more better with Hadoop than MongoDB or Cassandra, or at least you can say that it has known to be working well faster on Hadoop because Hadoop also provides a way to run programs on top of Hadoop. All right, a question from Ravi, but for fresh incoming data, not store data. Yes, for that you may want to use even Kafka or other services to do the processing of humongous data. A question from Saravanan is, but the use case of Spark is different from MongoDB and Cassandra, if I'm correct. That's right. MongoDB and Cassandra are designed to store fast the data that's being modified at a very fast pace, while Spark is designed for processing humongous data, which is stored elsewhere. All right. So you can think of MongoDB and Cassandra like a database, while Spark as something that can do the processing. All right. What is the example for data being modified continuously? The data that is being modified as in updated, the records are being updated, deleted, or particular values being updated and so on. Those records are called, that data is called modified, continuously modified data. Hadoop is great for if you are just using Hadoop file system. It's great for unstructured and only the uh, unstructured and append only data. While if you are using Hadoop for fast incoming data that's being modified as well, then we might want to go for HBase, which is also part of Hadoop. All right. All right. Now, most of your questions I'll answer through this discussion that we are going to start. All right. So out of these are basically only databases, while Hadoop and Spark combo provides file system, a database, as well as a processing engine, which is extremely powerful. Along with along this processing engine has many tools. So we would like to focus on this part because these parts can be explained in terms of these really easily. For example, Cassandra MongoDB are in parallel to HBase of Hadoop. So we choose Hadoop and Spark for this course because it's the most complete ecosystem. Second, it has second, it is open source as well as free, and it is truly distributed. All right, let's go through these and then I'll answer your question, Prasad and Razveer. Great set of questions. So keep asking the questions. That's the only way to learn. All right, so let's get started. And in case you all right, so hi there. Are you able to see me? And just to um, tell you that yes, it's a real person here answering your questions. So do not fall asleep. Okay. So if you have any questions, feel free to ask. I'm here. Great. So let's get started. Now, before we jump further into Hadoop and Spark ecosystem, let us understand the basics of Hadoop. All right, the various components and which component is used for what. So Hadoop was created by dog cutting from Yahoo. They were trying to build a search engine called Nudge, which was similar to Google, and they were kind of stuck and they were not able to move forward. Why? Because they realized that they cannot move ahead until they build the basic building blocks, such as a file system, such as a database, and such as a processing engine, which can run on thousands of computers. So they were kind of they could not move ahead, and that's when they that's when Google published these three wonderful papers were published by Google called Google File System, GFS. Second was Google MR called Google MapReduce, and third one was Google Big Table. And based on these three papers, Doc Cutting and Mike Caffarella, they implemented the first version of Hadoop. The GFS became Hadoop File System, GMR became Hadoop MapReduce, and Google Big Table became HBase. And that's how Hadoop came into play. The name of Hadoop comes from the toy elephant with which the dog cutting son was playing. And it is open source, specifically Apache. This is a most important part. There had been many systems which have been trying to there were many people who were trying to implement those three papers by Google, but most of them were closed source. And that's the reason why they did not become adopted globally. Since most of the systems that store data have a tendency of vendor lock-in, as in, if what if tomorrow this company just disappears, who will recover our data? That's why when it comes to storing important data, people prefer to use the open source. People prefer to use open source software, and that's the reason why Hadoop became Hadoop. Okay, Hadoop is powerful, popular, and well supported, and it's a framework to handle big data. All right, it is this last line is most important line. It is for distributed, scalable, and reliable computing. Initially, there were three components which were part of Hadoop. As of today, there are many components which are under the umbrella of Hadoop. Hadoop has become a big project in itself, under the umbrella of which there are many components. And these components, all of the components under the umbrella of Hadoop, share these three properties. They should be distributed, they should be scalable, and they should be reliable. And Hadoop was written in Java, though you can do the computing in many languages using Hadoop. For example, the first time I used Hadoop was using Python. There was no difference at all. And I was able to build a recommendation engine on top of Hadoop. And that was in Python. So even though Hadoop is written in Java, you can code using any programming language. All right. So I'm going to walk you through the ecosystem. So the first and foremost thing is Hadoop distributed file system. What is Hadoop distributed file system? Hadoop distributed file system is a storage where you can keep the file. All right. Now let me just give you how does give you an overview of how does Hadoop file system looks like. Let me make it full screen. And all right, so we are going to talk about Hadoop file system. Hadoop distributed file system is great. So I'm going to give you a quick demo of Hadoop file system. So I'm going to log in into CloudXLab. If you have created your account at CloudXLab, you can go to My Lab in your profile button, right? Just where your XP points are displayed, that's where it displays the My Lab. Under My Lab, you will see these multiple items. There is something called Ambari. All right, there were a question that I forgot to answer. Let me answer that question here by the way of writing. Now, since we know that Hadoop is an open source software, right? So Hadoop 1.0, the major contribution by uh, was by a company created by Dog Cutting and other associates. I think the company name is Cloudera. Okay, the other company which contributes to Hadoop's development is Hortonworks. And so both Cloudera and Hortonworks gives the same Hadoop, Apache Hadoop, along with accessories. Okay, along with accessories and their installer. Okay, these are the things that both Hortonworks and Cloudera ship. So they will basically provide the support, and of course they charge for the support. So if you are implementing Hadoop by yourself, you could use either of these. Okay, so they have multiple versions of Hadoop, one for Windows, Azure, and one for normal Hadoop, and as well as they have there is AWS, which has created a custom version of Hadoop which you can use. Okay, so these are the major two companies which provide the component, provide Hadoop for professional environment. Hadoop is free. You can use it for learning. You can use it for professional use. You can use it for production, the software that makes money for you. You can use it for all of those. The installer that we see it, the installer, okay, so the, in case of Cloudera, Cloudera has one good installer, while Hortonworks provides a wonderful installer called Ambari. So accessories, the Cloudera provides something called Hue, and Hortonworks provides something called Ambari. So what we have done is, as part of CloudXLab, we have taken parts of Hortonworks plus extra components from Cloudera. Okay, that's what we have done. That means you get best of both worlds. Okay, this is CloudXLab. CloudXLab basically provides you with best of both worlds. Okay, you can set up the access to the lab. You just have to make a payment of $1, which will be refunded very quickly to you, and you can just start using the lab. All right, the lab is free for 1 week. A question from user person is, can NiFi be used on CloudXLab? We'll try to do that. I need to discuss internally with my team if we could, because NiFi is something that people are asking for. We'll see if we could provide. Wonderful. So let's get started with say Ambari. you can see that Ambari, in Ambari, you can see all these components that are running. Ambari is a tool from Hortonworks, and it basically gives you an overview of the entire cluster. And since I'm administrator, so I can add more components and add more servers, add more services, and so on. Okay, so it may not be very useful for you because you don't have the rights to modify. Okay, so here let it load. We'll just wait a minute. Since we have recently moved to a new lab, the last night only we have upgraded the lab to Spark 2 and the new components. So there are some unforeseen things that are happening. So we are still optimizing the lab. Okay. We have done some optimizations recently, and we are observing right now we have put only three data nodes and three servers. So this is the first component that we are discussing. The first component is called HDFS. It's called Hadoop file system. It shows that the, out of 2.3 terabyte, 1.8 terabyte is free. So this is basically a storage. Now let's take a look at how actually the HDFS looks like. Okay, I'm going to go to Hue. Hue is a component, as I said, Hue is a component from Cloudera, which helps you interact with the environment. It lets you interact with various Hadoop components. Okay. Okay, so I'm going to. All right. All right. There is quite a few changes that you can see here. Okay, and all right. Also, I can switch back to an older version of Hue, that the one that I'm more comfortable with. So can you please explain Ambari exactly? So Ambari is the interface for administrators. You could interact with various components. You can add more computers to the network, and you can also see what's going on with the computers. So we can add new hosts, new hosts, as well as we can turn off, turn on various services. Say I want to shut down this service. I can click on that, and so on. So basically, Ambari lets you administer the entire cluster. All right. So on one hand, we have Ambari, which helps you administer cluster. On other hand, we have Hue, which lets you interact with various components so that various components so that so that you can like run a query or do the analysis of your data. All of that can be done using Hue. Okay, so I'm going to say data browser. No. Okay. All right, let me just go back to my files. Let me click on file browser again. All right. Since there is a version upgrade, I'm also a bit new to the new interface. All right, so this is my home drive in HDFS. Now, what is so great about this? The great thing about this is that this file system that you see, what is a file system? File system is like your C colon, D colon on your Windows computer, in which you have files and folders within folders and files within other folders and so on, right? That's what is called the file system. So here This is a great file system called Hadoop distributed file system, in which there are home drive for all the users. And these files that you see, some of them would be on one computer, some of them will be on another. And the amazing part is if one computer goes down, it will auto recover and move it to another. And that's how it would maintain its backup and so on. So that's the amazing part of Hadoop file system, that you can keep terabytes of data using so many computers. And in case a few computers go down, still you will have the backup of the data. It will have the auto recovery and auto backup between the various computers. Also, you can have as big file as possible. If you want to have 1 terabyte file size, you can have it in the Hadoop file system. So you can utilize thousands or thousands of hard disks on many computers in order to give a humongous storage. And that's the strength of Hadoop file system. Using Hadoop file system, you could store humongous data using many computers and many hard disks. All right. So that's what is this file system. This file system is something that make up the entire ecosystem, in which all other softwares also store this data. This is my data. For you, it might be empty, and you can upload the data using upload button, and you can also upload a file or a folder using you can create a folder from new and so on. Also, if you want to take a look at say exactly what's going on the server, and you are more comfortable with the Linux, you may want to go for like login into the terminal. I'm going to log into the terminal here. In this case, it may not display the password, but it works. Okay, so this is called console. Console is basically a Linux environment. Here you can type the valid Linux commands and interact with the system. If you want to talk to Hadoop file system, you can say Hadoop FS commands, and it will show you your files. Okay, while ls shows the local files on this particular computer, e.cloudxlab, while Hadoop FS shows you the files in the Hadoop file system. All right, so that's about a very brief overview. Those who are not yet comfortable with those who are not yet comfortable with Linux systems may want to go for, if you go to homepage of CloudXLab, you will find something called Linux Basics. So you can just click on Start, and you will find that the Linux basics, you can just start now and you can learn Linux basics for free. We have uh, it's a great set of 87 pages, which will make you comfortable with Linux file system, Linux operating system. All right, it's an automated assessment system in which it checks whether you have done it or not. All right, so make sure that you learn Linux before jumping into Hadoop development. All right, that's why we have created a Hadoop, a Linux file system. Sorry, that's why we have created a Linux tutorial. So do not miss out on this part. Okay, so make sure to learn Linux using this link, which I'm pasting in the chat. All right, so this console is essentially Linux, in which you can using this console you can interact with almost every component in the ecosystem. Okay, whether it's Spark, whether it's Hue, or whether it's HDFS or any of the components. So that was really brief about Hadoop file system. We will go into more details of Hadoop file system as we proceed. All right. In the second session of the course, we will start with Zookeeper. In the third session, we will talk about Hadoop file system, and then we will learn about rest of the components. All right, great. And a question from Rajesh is, does HDFS differentiate data based on where it is stored? Yes. So it is when we are executing something, then we can differentiate the data between where it is stored. Okay. So while HDFS takes care of internal rotation of the data, internal movement of the data based on which machines are free and which machines are um, heavy, which machines are busy. All right, great. Moving ahead. So the next component in the case is Yarn. Yarn is yet another resource manager. Now, as I just told you that Hadoop file system runs on top of many computers, meaning it is running like a service on many computers and it's keeping all the computers busy in storing the data. Now, which one will be better to you? To run the programs on the same machines on which you are storing data or run the program somewhere else? The answer is we should run the programs nearer to the data and therefore we should run the programs on the same machines on which we are storing data. This is something that we never did earlier. Earlier we'd kept, okay, we will keep the data storage separate and processing separate. But in case of Hadoop, we keep the data processing on the same machines where we store the data so that there is no network transfer when we are doing the processing. And Yarn makes it possible to keep track of which data is where and where should the program run such that your program can take advantage of the data locality, meaning your program can take advantage of running the process nearer to the data. All right, that's the role of Yarn. Yarn makes sure that your program runs nearer to the data. So you can think of Yarn as like an operating system which keeps track of which machine is busy, which machine is free, and which machine is having the data, and therefore it can run the program really fast, as well as it can guarantee the equal usage of your machines. So this is exactly the role of Yarn. Using Yarn and HDFS, rest of the components can do the data processing. All right, so the Yarn is something not visible to the end user, but you can take a look at various jobs that are running in the cluster by clicking on job browser. Say, for example, I was running some Hive jobs in the morning. Hive jobs in the morning. So you can see that these were the jobs that were successful. Okay, these were the jobs that were successful while they were not. Okay, so and you can take a look at that. I was just basically processing a file, processing some data using this kind of query. Okay, and right. So these are the. All right. So basically, using job browser, you can take a look at the Yarn that what all programs it was run. Also notice that these were the programs run by another component called Hive, but since it was running on Yarn, it is showing the jobs here. Okay, so you can think of Yarn as like an operating system like Windows, which runs only a single computer. Here, Yarn runs on multiple computers, and you can execute any program using Yarn. All right. Generally, the developers don't interact with Yarn unless it's about job monitoring, seeing the logs, or killing a process. Now, the next component is compute engine called MapReduce. This, com this compute engine called MapReduce is something that we used to program against earlier. So we used to write maps and reduce. We will break down our code. Instead of writing SQL query, we will break down our logic into two parts. One is called map, other is called reduce, and we'll hand over the map and reduce to MapReduce, and MapReduce will basically do a big sorting of the data and do the uh, you know the merging of the outcome. So MapReduce was a framework to do the sorting on big data. Okay, sorting on big data is what MapReduce does. So MapReduce underneath uses Yarn, and you can take a look at how to run MapReduce using Hadoop, jar, and you can run that. Okay, like for example, here I am doing some processing using Hadoop jar. All right, I just have to change these locations. Okay, I can just say current, and I'm hoping that it'll work. Oh, it did not work. Okay, so I can say 2.6. All right. So this is a simple example of we are trying to do some kind of processing on top of this humongous file. This humongous file you can see is okay. So you can see how big is the file. So it is around some few gigabytes, and we could do a processing of the data using Hadoop of such a huge size. I'll just show you. Okay. So this particular file, you can see how big it is. It is 7.7 gigabyte. So we can actually do the processing using multitude of computers. And let me just change the name of the output file. So I'm just doing some processing using that. And here I'm just giving a mapper program and a reducer program. And here it's going to process this data, this 7.7 gigabyte of data, and it'll save the outcome here. So this is just one example of how the MapReduce happens. And as you can see that in the job browser, it'll show that the process is running. Okay, the process is running. Now I'll have to kill this job because it'll take just too much time to run. It is going to be very resource intensive. And since there are just too many users in this class, I would like to keep it. You can see that it is going to run 62 parallel process to do the processing of this data in the network. So if you have like 62 machines, so it could actually utilize all of those in parallel. All right. So this is what we are right now doing. Great. So I've just stopped it. I'm not sure if, okay, this is my job. And if I remove the filter, I can see the jobs of other people as well. So I can see Saurabh Saxena and other users are right now using the system. All right. So this is basically how the Spark and Hadoop looks like. I'm sure that it's not very clear to you right now, but if you follow along in the session in the upcoming classes, you will get a hang of what's going on here. All right. Now I'm going to just do the hands-on with various components. The other components, important components, is Spark. Spark is a competitor, or you can say cousin of MapReduce, which does exactly the same work as MapReduce of processing data humongously. All right. So this is basically what we call Spark. Spark we are going to discuss in detail in a minute, right? The next important component is HBase. HBase is like a NoSQL data store in which we can store data in the tabular format. So you can take a look at, let's say, data browser and click on HBase, and there you can create a database table and can upload the data there. All right. You can basically create the database there, or the other way of launching HBase is using HBase shell. That's the command to launch HBase. Okay, so all right, so we can say create. We can pass the create command from here and create the tables in HBase. All right, let me try to see if there is any other cluster or something. Okay, so using here we could say create table and create our table on HBase, just like we do in MySQL. All right, we will cover more details about HBase in the upcoming sessions. Okay, so let's go ahead here. All right, next is the next component that we would like to talk about is Hive. All right. Yes, HBase is a kind of competitor to MongoDB, and it can be used in place of MongoDB or Cassandra very well. All right. The other important component is Hive. I like to use Hive for, so I could basically go to here, and exit the console and launch Hive. Okay. Using Hive, we can interact with Hadoop MapReduce by the way of SQL. Say, for example, I am running this particular query, which is going to do some processing on top of Hadoop cluster. Okay. So those who are comfortable with SQL, they can see that I'm processing a particular table. The table is essentially a physical file that's being processed here. Okay. So we have created a table in Hive, which is essentially kind of a view on top of a file. And by the way of this, it's underneath, it is executing the MapReduce command. As you can see, it's running the MapReduce. Okay, so let me make this screen a little bit smaller so you can see it's launching the Hadoop job. All right, so essentially the Hive command is the one that you can utilize for running any SQL queries on structured data. And Hive is great for relatively static data, processing of the data, not really modifying the data, while HBase is great for modifying the data at a fast pace. All right, so I'm going to stop it because I think a lot of users are right now logged in. And yes. Great, great. So this was a quick overview of the command called Hive. Using Hive command, we can we can actually process really huge data using SQL queries. Okay, that's the role of Hive. Pig was a cousin of SQL. Pig was a cousin of Hive, which people still use. And using Pig, we could process a lot of data and a lot of big data using Spark. All right, does it exit? Let me see if I can exit. Wow, it is not letting me exit. Okay, yeah, I had to press Control C to come out. In case you get stuck, you can also use Control C. So Pig was very similar to Hive, but it's not much used. It was a new language. That was the reason why it failed, because it's not possible for industry to migrate to a new language. It used to have its own language like Pig Latin, which is similar to SQL, a little bit more for unstructured data. All right. The other one was Mahat. Mahat was for machine learning, but it has been replaced largely by Spark. All right. In a typical use case, when you have a larger project, you will have some work to be done on HDFS, some file to be moved, some file to be copied. All of that needs to be done using Oozie. Using Oozie, you can move the data. You can move the data between the system, run a Hadoop MapReduce command. All of the things that you see in this ecosystem can be done using Oozie. Now, those who are wondering that what does it mean by Scoop and Flume, Scoop is used for moving data from your structured sources. If you have, let's say, traditional database, your existing data warehouses, and you want to move the data from your existing databases, then you can use the Scoop. Scoop is a good command to. Underneath, it is also using MapReduce, which is going to copy the data from one place to another. To understand Scoop, you can use Scoop help and take a look at how to use it to move the data from SQL to Hadoop ecosystem. Then there is a command called Flume. If you have continuous data coming in and you would like to pump the data continuously into HDFS, then you would like to use Flume. Flume is essentially for continuous pumping of the data from unstructured sources or any kind of sources into Hadoop ecosystem. So Scoop and Flume are for taking the data from outside towards the Hadoop. Even Scoop is used for taking the data from Hadoop to structured data sources. Let's take a quick use case of building a recommendation engine. Recommendation engine you could be building based on the logs of your website. Let's say you are running an e-commerce company, and at e-commerce company you're storing um, the user behavior continuously in the form of the website. On the website, you are continuously storing the data in the logs. So using Flume, we will pull that data from your website to HDFS first, and that's where the Flume will be used. The second one is using the normal tools like Spark, Hive, or maybe Pig. We will clean up this data and put back in HDFS. Once we have cleaned up the data, we'll feed the data to a machine learning library such as MLlib, which will have the algorithm for recommendation engine. The results of MLlib will be stored back in HDFS, and then using Scoop, we'll take this data from HDFS and push it to the MySQL or any other database. From MySQL or any other database like Microsoft SQL, Oracle, we can serve using a web server to our users. So if you are building an e-commerce company and in there, if you're building a recommendation for an e-commerce company, this would be your typical flow for generating the recommendations. As and when the data is coming in, we are using Flume to pull the data from traditional file system to HDFS. Then using a Spark, Hive, or any other combination, we are cleaning up the data. Then once we have cleaned up the data, then we feed it to MLlib. From MLlib, we are generating the recommendations and keeping in HDFS. And from HDFS, we are pushing that to MySQL using Scoop. And from there, from MySQL, the recommendations, these are the recommendations we have kept here using Scoop. These recommendations are being served to the end user by the way of a web server. Web server is reading the recommendation from this database and serving to the end user. So this is how a typical flow of building a recommendation engine looks like. And this is a typical use case of big data systems. And when you have such a complex flow, and it's very common to have such a complex flow, you would like to use a Uzi workflow engine, which will take the entire flow and execute it based on data availability, based on a time schedule, or based on any other file availability, and so on. So using Uzi, you can automate a lot of workflow. So you can take a look at Uzi here. You can take a look at Uzi here. If you click on Job Designer, you'll be able to take a look at Uzi, and you can drag and drop all kinds of functionalities here. Okay, let me see how does the new editor look like. Okay, so where did it go? All right, let me just create a new, right? So here you can simply all right, I'll just show you using old designer. So here you can create a new action. Action could be anything. It could be MapReduce. It could be running a Java program. It could be a like Hadoop streaming tool which can execute any program. And it could be Hive. It could be Pig. It could be Scoop. It could be Hadoop FS command, and it could be SSH, and so on. So using this editor, you could. So not this one. Okay, so it doesn't look really nice. Okay, so let me just create a new workflow. Okay, so I can create a new workflow. All right. Say, take a case of this example whereby we have pig and hive. We can drag and drop. All right. We can click on, say, Woozy dashboard. Oh, it doesn't have. All right. So basically, it provides you a nice editor which you can use to drag and drop and create any kind of flow. Okay. So for some reason, since I've moved to the new editor, it's not giving me the drag and drop view. All right, let's just wait here. All right, so basically you can create this whole workflow using Oozie workflow by dragging and dropping Spark, MLlib, Flume, Scoop, and all of these components here. All right. Let me see if I could see the new version. I'm also, since we have just updated it today in evening, I'm also kind of new, so it's fun to browse through a new component. Though the commands would remain the same, just the UI of Hue has improved a bit. All right. Let me see if in the new one it looks good. All right. So this is how it looks like. Let it load. So basically, the Oozie workflow will get everything done using a nice UI. Also, if you don't like UI, you can also create an XML which you can give as a workflow. All right. So using that XML, you can basically define the workflow and rest will follow. All right, let it load. Okay, what's happening with this? Okay, does it have, okay, so all right. All right, looks like, all right. So I'm not able to locate a place where I can edit it. Generally, there is a way to quickly edit these workflows, and for whatever reason, it doesn't seem to give me that editor. Okay, so, all right, never mind. So I think we'll just have to enable it somewhere, and that'll be good. Okay, so you can add the libraries and you can schedule the jobs here using probably this and save it and then execute it. All right. So using the Hue, you can create the entire workflow, and just I need to take a look at how exactly we need to do in the new dashboard. All right. In the older dashboard, it was drag and drop, and it was really user friendly. I just need to figure out whether the user interface has changed, or is it that I don't have permission to run it. All right, never mind. So let's move ahead. And the next big component of Hadoop ecosystem, after Hadoop ecosystem, is Spark. Spark is a processing engine, and it's a general purpose. It's a fast and general purpose engine for large scale data processing. All right. So using Spark, you can do any kind of processing, whether in the form of SQL, using Scala, using Java, using Python. You can use any programming language or any kind of query mechanism to do the processing using multiple computers on top of humongous data. That's the role of Spark. Spark provided something Spark provided something which was better than what it was provided by Hadoop in the form of MapReduce. So Apache Spark is essentially a competitor to MapReduce. It's really fast MapReduce. It's around 100 times faster than Hadoop MapReduce in the memory, 10 times faster on the disk, and it builds on a similar paradigms as MapReduce. Apache Spark builds on similar paradigms as MapReduce. It's very well integrated with Hadoop. It takes care of running the program nearer to the data. So Spark can run on top of Hadoop. It can run on top of EC2. It can run on top of other competitors of Yarn, such as Mesos. And if you don't have any other cluster installed already, then Spark also provides its own cluster manager called standalone. All right. So Spark did really clever thing. First, it made it possible to run it on top of Hadoop. Second, it made it run on all other similar cluster managers like Hadoop's Yarn, YARN, Yarn. Yarn is for yet another resource negotiator. So, and it also made it possible that if there is nothing, you can use Spark's standalone. Now, the wonderful part of Spark was that it was it is capable of reading data from HDFS, HBase, Hive, Tachyon, now it's called Elixir, and Cassandra, as well as MongoDB. It can read the data from all these sources and can do the work on top of all of these. Also, Spark provided something called data frames. Spark also provided a library to do the processing of the data that is coming really fast. Spark also provides a library for machine learning. As of today, MLlib is very sophisticated library for doing the big data machine learning, meaning doing the machine learning. Machine learning is nothing but doing predictions and doing predictions on top of unstructured data, structured data, or doing unsupervised or supervised predictions. All of that is part of machine learning. Machine learning is figuring out the pattern in the data, and so Spark provides a very wonderful library called MLlib. It is extremely powerful. Spark also provides a wonderful graph processing tool, which is far better than any of the competitors. It's called GraphX. GraphX is actually better than all of the competitors available, even the competitors which are as in paid competitors, as in the where you have to pay a lot of money just to use library. GraphX is far more powerful than those. So GraphX, MLlib, streaming, and data frame, these are the libraries of Spark. Other than the core Spark, most of these libraries are built on top of Spark. You can use Spark SQL, you can use Spark or any of these libraries by the way of SQL, R, Java, Python, Scala. You can use any of these programming languages to interact with Spark. I'll just show you if I'm able to launch PySpark. All right, so we can launch PySpark. Okay, so you can see that there are so many users already using Spark, and here this is the PySpark. So I'll just try to see if we can run data equals sc dot text file spark dot spark.read.text, and the data I'm trying to read is in the data mr at this location called word count and input. Okay, what does it say? The path does not exist. Data mr word count. Okay, so you can see that it is I'm able to read some text from HDFS using Spark. All right, if you are interested, you can also try PySpark and this line. And okay, so that's an easy one. Now, this is actually Python. This is actually Python where we were writing code in Python. In case you don't like Python, you like, say, you like Scala, then you can do that using Scala as well. Okay, using Spark Shell, I'm using a command called Spark Shell. Using that, we can launch the Spark Shell. Okay, so here we go. And let's just show you how to load the data using Spark. So I'm saying, all right, so you can say lines.take. I can do all kinds of processing on this text that is being loaded from HDFS. This location is in HDFS. All right, so that's about processing using PySpark and Spark Shell. These two parts we have just covered. You can, in the similar way, you can also do R and SQL. I'm not sure if Spark R would work. So you can say Spark R. Yes, you can see it has launched Spark R. Now here you can write your code using R. Okay, so this is R. So you can interact with Spark in any of these languages. All right, I'm just going super fast and not covering too much detail because we'll cover these in more details one by one. It'll take me a long time to describe you each part in more details. So we would, right? So that's about what Spark does. Spark basically provides you all these libraries in a very, very simple manner. You can use all of these languages, Scala, Python, Java, Spark R, or SQL, and interact with big data without having to worry about how do I distribute my data or my code. All right, so all of that work is done by Spark. All right, so you can also use Spark SQL in order to do the job. So that was about the Spark's architecture. We also went through the components whichever was required, and to go more details about these, we will basically cover this in one chapter, one chapter, these two in one chapter, and we also will cover this in around 3-4 chapters. And there are a few more things we will learn as part of Spark: how to run it on the cluster, how to optimize the jobs, how to uh, understand what's going underneath, and we learn advanced Spark programming in order to do the extreme optimization. All right, so that was about Spark. Let me answer your questions. I'm sure you'll have more questions. All right, so that was about Spark, and All right, a question from Prasad is, what tools are available to move the data from on-premise SQL Server Oracle to cloud? You could use um, the standard tools like rsync to move the data from local to remote, or you could use the Flume engine to push the data from local to the remote. Okay, or if your SQL Server or Oracle is available publicly on a public IP address, in that case, you can use Scoop. You cannot use Scoop if your database is not accessible from the machines on the cloud, because Scoop is nothing but is running the job on multiple machines, and all these machines will connect to your SQL server. All right, so you can run a Scoop only on the cluster. Therefore, you will either have to use, say, a tool like rsync or RCP and so on to, or make your SQL Server or Oracle data available on a public IP address so that your cloud cluster can pull the data from there directly in an efficient manner. Good question. Good question. And let the question coming. And a question from Prasad is, Scoop and Flume are cloud-based tool, or do we have to use the tools from on-premise as well? So Scoop and Flume are command line based tools. Scoop continuously runs while, sorry, Flume continuously runs, and Scoop is a batch tool, as in we run it, it does the job, and it ends. While Flume, once you run it, it'll continuously keep on running. So they are both run on the Hadoop cluster. A question from Yashit: how long does this recommendation engine take to generate and push to the web server a generic recommendation? It is a function of how big is your data. If your data is a million records, it will finish really quickly. If it is, say, 20 million records, it might take a long time. All right, so it's a function of how big is your data. A question from Naveen: can we use C# as well with Spark to process data? That I'm not sure. Okay, that I'm not sure. But if you are able to run C# on a program, then probably you can run it using streaming and calling the system command. You can definitely launch C# program if you are running on Windows. But I'll have to take a look. How to create different nodes on my computer using virtual machine. Do you have a guide on this? So you can take a look at say we had a Hortonworks installation that we had put earlier. Probably if you leave on the discussion forum, I'll share it there, the exact link of setting up. All right. Okay, so somebody has a question. Please feel free to ask using the Q&A window. Yes, Veena? Yes, thank you, Abhinav. So here is the link. Here's the link for doing the installation. Okay, and you can take a look at that one. How did we set up the CloudXLab on the cluster? All right, so the same mechanism could be used, or you could use, say, HDP VirtualBox. So there is here they provide a virtual based environment which you can download and install. Okay, so take a look at that one. They provide the image that you can download and install. A question from Ravi is, in one program, can you use all the languages in Spark together? The answer is no, but Java and Scala you can use in a project together. All right, Java and Scala you can use in the project together, but using Python and Java or Python and Scala is going to be hard, but you can use it by the way of using the system command and calling them from outside. All right, great question. Can you compare Spark to ETL tool like Pentaho? Pentaho is basically something that is non-cluster based. Pentaho is like a BI tool, is an analytics tool. You can use Pentaho with Spark, while Spark makes it possible to do the processing using many computers. ETL tools like not ETL tools like BI tools like Pentaho BI or other tools can use these services to give the results. Okay, so the backend for Spark for Pentaho could be Spark SQL. A question from Devashekhar is, does Hadoop support adding or deleting computing node dynamically based on input size or variety? No. So deleting or adding computing nodes is a function of the installation or administrator. Though while based on the input size and variety, we can choose to spread the work to many machines or choose to run it only on few machines. That control we have as part of Spark. So when you are processing using Spark, you can say that please run it on 50 machines or please run it on only 3 machines. By the way of tweaking something called partitions in Spark, we can change the allocation of the resources in the network. All right. A question from Naveen is, what is the best language to interact with Spark? So a quick answer to it is Scala, because Spark is written in Scala and Scala is extremely simple, just like Python. So somewhere between Python and Java is Scala. So that's why we have chosen the Scala to be the language for this course, and we will teach Scala as part of this course. Okay, before we start with Spark, we will first teach Scala so that you don't have a problem with anything. As part of this course, you don't have to worry about learning a language because whatever would be needed will be taught as part of the class. You only need to be okay with SQL in order to get started with this course. A question from Prashant is, like Flume, do we have other tool for structured data which keep running without having it to schedule? Yes. So we have okay, so all right, so Flume is for pushing the data, and Flume can take care of the structured data as well if you want to just push the data. And if you want to do the analytics on top of structured data, we have something called structured streaming as part of Spark. All right, so we have something called structured streaming as well as unstructured streaming, both as part of Spark. If you want to process the data continuously, if you want to just push data of any kind to the cluster, then Flume is good enough. A question from Anil is, can Hadoop work if the servers are in different geography? Yes, it can work, but the performance may not be that great. But we call Hadoop as rack aware, meaning we can configure that which rack is nearby, which rack is far away, based on the topology of the network. All right, so great set of questions, and I'm really honored to have wonderful set of audience today with great questions. Please keep the questions coming. We still have around 7 minutes, 6 minutes now. All right. A bit about the course. In this course, we are going to go deep dive into every component in Hadoop and Spark ecosystem in details, and in a very hands-on manner. All of the components that we have talked about, we are going to do hands-on, as well as we're going to there are exercises which you need to complete in the CloudXLab in order to get the certificate. All right, we have a certificate course, and okay, so a question from Rajveer is, Hadoop can be used with MongoDB cluster. So yes, there is something called Mongo Hadoop library with which you can do the bridging between Hadoop and MongoDB. All right. Also, you can run parallelly MongoDB as well as Hadoop, the way we have done in case of CloudXLab. A question from Rachna is, why do we need to use Cassandra and MongoDB when we have Spark? So Spark is only for processing. Spark does not provide the storage. So it is up to you whether to use HBase, Cassandra, and MongoDB for storing structured data which is being modified continuously. You use a NoSQL such as HBase, Cassandra, and MongoDB when you want to provide a huge write, a very fast a system which is capable of handling lot of writes in a minute or in a second, lot of modifications to data per second. In those cases, you use a NoSQL server like Cassandra, MongoDB, or HBase, while the Spark you use for doing the processing on the data. All right. A question from AK is, sorry to repeat, but can we use Pentaho PDI instead of Spark? I'm not sure. I only use Pentaho BI, but we have not used PDI yet. I'll take a look and see if you leave your question on the forum. The forum is available here. If you go to CloudXLab, you'll be able to see discussions. Okay, so this is the forum. All right, this is the forum. You can ask your question here. I would love to answer your question. All right, so I'll also do a research and will answer you. All right, question from Pankaj is, what is the difference between HBase and HDFS? The answer is HDFS is for storing files and in the form of folders and so on, while HBase is for storing the records. Just like on your computer, you have C colon, it has folders and files. That's like HDFS. And you have, let's say you have a Excel sheet in which you are keeping the records and columns and files, columns and rows. That's equivalent of HBase. At the end of day, the Excel sheet, Microsoft Excel sheet, is going to be stored in your C colon. In the same way, when you are storing data in HBase in the form of columns and rows, the data is going to be stored in HDFS. All right. So that's how you can think of it. HDFS is like your local file system, like C colon in your machine, while the HBase is more like Microsoft Excel. All right. Couple of more questions. A question from Anil: how Hadoop can help in banking industry? So in banking industry, there is a lot of data, and whenever there is a humongous data, we can use Hadoop specifically for analytics on the older data, on a various kinds of logs. You can use Hadoop. All right. For transactional data, you may not like to use Hadoop, but for the archival data or for data warehousing, you can use Hadoop and do a lot of processing on your user behavior or users the archived transaction data. You may not prefer to use the Hadoop for transactional data, because most of the big data systems do not provide transactional support because of most of the computing being done parallelly on multiple computers. All right. How does HDFS handle scaling? Can we add new systems in the distributed network dynamically? Yes, but not like it won't increase automatically. We will have to, let's say, go to Ambari and then go to hosts and then add more hosts here. All right. If you need more data, we can keep on adding more and more hosts into it, and that's how we generally take care of the HDFS scaling. Okay. And question, so I hope that answers your question. Question from Naveen is, certification of big data and ML is free. Can we do ourselves? Yes, you can do yourself. The big data and our course, that one we have, that one does not have everything free. Some part of the big data course are free. All right. So you might have to buy the course. A question from Prashant is, which date are we targeting for course Hadoop plus Spark completion? Let me be honest, the course might take more than 2.5 months So you'll have to plan accordingly. Question from Prasad is when to use Pentaho versus Scoop. Scoop is for pulling the data from SQL into Hadoop parallelly using many computers, while Pentaho, I'm not sure how it works. All right, I'm not sure if it'll basically copy the data from SQL in a distributed manner. A question from Dave Sekhar is, as Spark is a computing engine only, can be Docker container as Spark compute nodes? Yes, you can. But again, with the Docker container, you may not take the advantage of data locality, right? One of the biggest point in case of big data processing system is that they take advantage of running the logic nearer to the data. But if you are launching a new container, the new container may not have the data, and therefore you may have to remotely fetch the data for that particular container. But yes, it is very much possible to launch Spark in the Docker container. A question from Rachna is, could you provide specific instances on when to use RDBMS and when to use NoSQL databases? So as a thumb rule, if you need a very strong transactional database, you use the RDBMS. When you need very humongous data storage, as well as you need a heavy write support or heavy read support, in those cases you use NoSQL databases. That's one of the simple. Most of the NoSQLs do not support the ACID properties. ACID properties are the four properties that most of the databases live by. A for atomic, C for consistent, consistent, I for isolated, and D for durable. Those are the four properties most of the relational databases swear by, or they all abide by those four premise of the transactions. But in case of NoSQL, ACID is not supported. Instead, they support something called eventual consistency, and there's a good reason for that, because since the systems are running in parallel, it's very difficult to have immediate reflection of the data on another computer at the same time. Therefore most of the systems provide eventual consistency, not the immediate consistency. A question from Karthik is, why run two databases parallelly? Internally, HBase or MongoDB or Cassandra, all of these run the data instances parallelly because that way it can scale very well. That's the main problem most of the big data systems are solving. Handling huge velocity of the requests, handling huge data, and handling the failovers of handling the failures of the hardware. That's exactly what most of the highly distributed system are great at. All right. A question from Rajveer is, yes, NoSQL support ACID property. Which NoSQL does support ACID property? I would love to know. Please drop us on the forum. I would love to discuss it in a detail. Come over to the forum, and this will be great to have a discussion there. All right. A question from Prasad: what's the main difference between HBase, MongoDB, and Cassandra? The difference is in the form of structure of the data. In HBase, we have the flat table kind of format. The MongoDB has JSON kind of a format, while for each row. And Cassandra has similar format like HBase, but Cassandra has better query language than HBase. Also, in case of Cassandra, you can fine tune the consistency and consistency as well as the replication factor. A question from Yuvraj is, using HBase, we can store the data in the local computer or in the database. So HBase stores the data on the cloud, and under the hood, it stores the data in HDFS. A question from Yashit. A question little off topic to the course material. Which OS do you suggest? In very simple words, we suggest Linux. There's no doubt about it. If you want to rise in the career, I would strongly recommend that you learn Linux. And this is an answer to all of you. Maybe I believe that I've not seen a single backend engineer handling big data on Windows. All right. So this is a strong suggestion to all of you that if you want to rise in the career in specifically in big data and machine learning, make yourself comfortable with Linux, because the same Linux commands are going to be available very soon on the Windows, and therefore the, therefore that command that learning of Linux is going to be extremely useful. The second reason is that if you learn Linux, you'll be able to automate a lot of things, and almost everything is available on Linux console, whichever you want. Like for example, you want to start learning Python, you can just say Python and you can start learning. If you want to start learning, say R, you can just say R here and then it'll launch R. So everything is there on the Linux console. So that's my strong suggestion to start learning Linux. There is no doubt about it. All right, question from Rachna. If the session is recorded, could you please send it to all attendees, the recorded session? Yes, this session is recorded and we will be sharing it with all of you. All right, so wonderful set of questions. I would love to see you in my session in the next class, in the next session, which is going to be on Saturday. We will start from Zookeeper, and then we'll move forth towards Spark and more details. And all of it is going to be very hands-on. All right, so yes, for all of you, we will be sending the email. If you miss out from the email, just send us an email at reaches@cloudxlab. We will ensure that you get the recordings as well as slides for this session. All right. A question from Expla. Which ETL is preferable as a beginner? All right, this is a very hard question. I would say that even if you're a beginner, you get started with Hadoop. It won't harm you. Instead, it'll force you to learn various components. All right, great. Wonderful to have you all in the session. I'm extremely happy that around 70 participants were in the session till 11 o'clock. That's a rare thing to have. And I'm really lucky to have great audience. And I'm happy that all of you had a patience to hear out the questions from others. And I'm sure that you will be able to utilize this knowledge. And if you have any questions, come over to CloudXLab, drop a mail to reach us at CloudXLab, or drop by to our discussion forum. There's a lot of questions out there, a lot of people discussing. So please feel free to come over to the discussion forum and ask the question. We enjoy, as a team, we totally enjoy answering the question. And in case you know the answer to other person's question, feel free to put forth your views. All right. Thank you, everyone. I'm really honored to have all of you in the session. A great set of questions and a great set of learning for me. All right. Thank you, everyone. I hope you can see the video. I look forward to see you in my next class. And I thoroughly enjoy answering your questions. Thank you, everyone. I look forward to see you in the next session. Thank you to my team who has done a wonderful job of answering your questions. And most of my team members are passionate about the user responses. All right. Yeah, it's a new window. I have put a poster out there, and it's failed attempt to mask it like a window. All right, so the next session is going to be on 21st, 5th of August, which is going to be next Saturday in Indian time. All right, so 8 p.m. to 11 p.m. It's wrong actually here. It's going to be 8 p.m. to 11 p.m., not 10 p.m. So I'm going to correct it. So it's 8 p.m. to 11 p.m. IST, and all right. Great. Great. Wonderful to have all of you in the session. And I hope the session was useful for you. Bye-bye. Have a good day. Thank you, Razvi. Thank you, Billy. Thank you. Thank you, Raghu. Thank you for being a great audience. Thank you, Mohammed. Thank you, Anil. Thank you, Yashit. Thank you, Lay. Thank you, Ashok, Silvio, and Deepak, and Ravi. Come over to the sessions. I'm sure you will enjoy. And the questions are, the sessions of ours are very discussion oriented. So why do we do that? Why do we have discussion oriented sessions? Because we realize that even if you memorize everything, you won't be able to recall in your interviews. You won't be able to recall any of the learnings if you don't discuss. All right. So if you are solving a problem, you won't be able to do it unless you discuss. So most of our sessions are very discussion oriented. Generally, we have at most 20 people. We still have, like, I think, uh, 2, 3 seats. I'm not sure, they will be filled by now. Okay. So all right, so feel free to come over, and if you go to CloudXLab, click on Enroll, and you'll be able to join the class. All right, great, great. Stay connected. We are coming up with many things on our lab, and we are basically building a lot of interesting things in the domain of learning, and which could be useful to you, if not now, maybe in the in as you proceed in your career. Those like we are about to launch a SQL course for free that will be available to you, all of you. All right, great. Bye bye. Have a good day. I look forward to see you in the next session. Come over to CloudX Lab, and you can enroll for Hadoop, Spark, or machine learning specialization. All right. Bye bye. Have a good day. Bye. Thank you, everyone, and bye bye.